In this video, we're going to be looking at the final review, specifically for Unit 2.3 or Chapter 2.3, which is over quadratic functions. So to start us off, let's talk about comparing between vertex form and standard form when we're graphing quadratic functions. So when we have something that's in vertex form, that's going to look like an equation that has the parentheses. So I'm going to draw that out for us. Let me make a line here to also compare this with standard form. So if I have something that is in vertex form, like I said before, that's the one where we have parentheses and we look at the shifts. So just as a quick reminder here, if the inside of the parentheses is a minus sign, we're going to be going to the right. If we have a plus sign, we're going to be going to the left. And on the outside of the parentheses, that's our vertical shift. So plus sign means up, negative means down. So vertex form is great for finding vertex because you just look at the shifts. So when we are thinking about graphing for vertex form, finding the vertex is one of the key things, which is the middle of the parabola, which is looking at the shifts. So what's inside the parentheses and what's outside of it to be able to tell which way it went, whether it's right or left or up or down. So you look at the shifts to determine the vertex. For the y-intercept, this is where it gets a little bit tricky, but to find the y-intercept, you have to plug in 0 for x and then find y. And that's because anytime you want to find the y-intercept, if you plug in 0 for x, you're going to find the number that sits on the y-axis. All right, let's take a look at standard form. So for standard form, that's when we have an equation that has the x squared that comes first, then usually the x to the first power next, and then the constant. And so what's the nice part about standard form is the c, or the constant, is your y-intercept. So it's really easy to identify the y-intercept because it's always your constant if you have it in standard form. So the vertex is the part that's a little bit more challenging to find. You have to use a formula. So the first step is to use that formula, x equals negative b over 2a. And then the second step is once you find x, you're going to plug in x and find y. Kind of like how you would find the y-intercept here, only you actually have to find x first using this formula and then plug this x value into the equation and find y. So that will help you find your vertex. And like we mentioned before, the y-intercept, you're just going to use your c value or the constant value from the equation. So it just end up being 0c. So if you were to graph it, c here would be the y value for your y-intercept. And so we'll apply this to the problems down below where it's going to ask us to graph. So in problem 28 here, it says, given the quadratic equation, so here's our quadratic equation, it says to describe the transformation and state the vertex. So transformation is talking about the shift, and notice it's in vertex form. So when we look at vertex form, we need to look inside the parentheses, and our inside has a plus sign on the inside the parentheses. So the plus sign means left. So this is going to go left 2. So I'm going to write that down here. So left 2 units. And it looks like when I look on the outside here, there's a plus 4. So if you have a plus sign, it's going up. So it's going up 4 units. So up 4 units. And that is going to be our transformation. So the transformation is actually describing the vertex. So if I were to graph this and go left 2 units on the x-axis, I would be at negative 2. Then if I were to go up 4 units, I would be at positive 4. So if I were to place my vertex here to draw my parabola, I would have it at negative 2, 4 for the vertex. So my vertex is negative 2, 4. And that's it. Now, I don't need to draw the parabola here, but if we were, remember, you can always use a slope. So the slope in front of my x here is a 1. So I can write this as 1 over 1. I would go up 1 over 1. So if I were to extend this to 5, go up 1 over 1, and then up 1 over 1, connect the dots to draw my parabola. And that would be my parabola. But it doesn't ask me to graph here, but just so you guys practice a little bit of graphing. Let's get into our next problem where it says, what is the y-intercept and the vertex of the parabola? And whenever you're trying to find the y-intercept and it's in standard form, remember, it's just the constant value. So you might remember from this one here, if it's in standard form, c is always the y-intercept. So in this case, my y-intercept is 12. But don't make the mistake of writing just 12 down for your y-intercept. Remember, your y-intercept is a coordinate. It's going to be 0, 12. Because if you were to place on the y-axis at positive 12 here, the x value there is going to be 0. So that's why I'm going to write it as 0, 12, because this here is a coordinate. The y-intercept is always a coordinate. Now for the vertex, I have to find that as well. And to do that, I'm going to need to use the formula for standard form. So the formula for standard form you might have saw earlier is this formula here. We have to find x by plugging in our b and our a. And then once we find x, we're going to take our x and plug it into our equation to find y. So our x here is going to be equal to negative b over 2a. And our b here looks like it's a negative 8. So negative 8 over 2a. And our a here is 4. So if I plug everything in, and just a reminder, this is our a, b, and c that I'm referring to. So if I were to plug this into my formula here, looks like the top ends up being a positive 8. And the bottom is also an 8. So 8 divided by 8 is 1. So it looks like our x value for our vertex is 1. So I know what x is. I need to find y. So I use my formula here, or my equation, and I plug in the 1 in for x. So that's kind of nice because 1 is easy to multiply or plug in with. So if I plug in 1, I would just have to do order of operations, so parentheses first. Now there's nothing to simplify inside the parentheses, so exponents come next. So 1 squared is still just 1. 8 times 1 is 8, and then I'll bring down the plus 12. So this ends up being 4 minus 8 plus 12. So if I take 4 and I subtract 8, I get negative 4. If I add that with 12, negative 4 plus 12 is positive 8. So it looks like my vertex is at 1, 8. And that's it. So our next problem is kind of the same. We're finding the vertex, the minimum, and the y-intercept. But this is in vertex form. And we also need to graph it. It looks like here to the side there is a graph for us to use. So to start with this problem, I always like to start with finding the vertex if it's in vertex form. So if there's a plus sign on the inside, this is going to be shifting left 2. If there's a plus sign on the outside, this is going to be going up 3. So if I go left 2, up 3, and I were to plot, there is going to be my vertex, which is at negative 2, 3. Now, I don't know if it's a minimum or a max yet. I need to graph the other 2 points. So remember, a parabola typically has 3 points, the vertex, and 2 points to the side. So the slope in front of my x is a 1, so my slope is 1 over 1. So I'm going to go up 1 over 1 and plot, up 1 over 1 to the left and plot, and then I'm going to connect the dots to make my parabola. Now, once I've made my parabola, I started to notice that this is the vertex, and the vertex looks like a minimum because it's the lowest point on the u, or the parabola. The y-intercept, I can't really tell where the y-intercept is because I can't see this curve hit the actual y-axis. So this is where I want to calculate it. And so you might remember from our notes here, it says to find the y-intercept for vertex form, you got to plug in 0 for x and find y. So if I were to plug in 0 for my x, and then find the y, so if this is x and this is y, let's use our our equation here. So we plug in 0 for x plus 2 squared plus 3. Working this out on the inside of the parentheses, I would have 2. 2 would need to be squared. 2 squared is 4 plus 3 is 7. So it looks like my y-intercept is at 0, 7. Okay, so that is pretty much it for the problem. Another thing I want to mention, and we don't talk about it with some of the problems, but just as a reminder, you can also cut your parabola in half. It always goes through the vertex, and that also helps you mirror your points to make a reflection, to make your parabola as symmetrical as possible. So we call this the axis of symmetry, and in this case the axis of symmetry hits it at -2 on the x-axis. So this axis of symmetry is at -2 for x. Alright, so getting into this next problem here, we have something that is in standard form, and so we can always find the y-intercept quickly on standard form. It's always the c value or the constant. So if this is our a, b, and c, our c is always the y-intercept, so it looks like it's at +4. So I'm going to go ahead and place that point on here. So at +4, that is the y-intercept. So that's going to be at 0, 4 as a coordinate. Now, I don't know how many solutions yet because I haven't graphed the parabola, and so I don't know where it crosses the x-axis, so I'm going to leave that blank for now. The vertex coordinate, I could use that formula, x equals -b over 2a, to find the vertex. So my vertex has an x value and the y value. So I'm going to use that formula because we're in standard form. So if I plug in my b here, which is -4, and my a here, which is -2, and I simplify, this would be 4 over -4, which is -1. So my -1 is for x, and to find the y value, all I have to do is plug this -1 into the equation, and then find my y. So this ends up being -1 squared is going to give me +1. And then these two negatives multiply will make a +4 plus 4. So we're getting closer. -2 times 1 is going to give me -2. And then 4 plus 4 is 8. So it looks like -2 plus 8 is 6. So my coordinate ends up being -1, 6. So I'm going to go ahead and plot that on my graph. So -1 up 6 would be up here. And this is the vertex. So that means that's the middle of the parabola. So if I were to draw an axis of symmetry through the vertex here, it looks like this point here can be reflected over the axis of symmetry. And then from here, I just want to try to connect the dots as best as possible. Let me redo that. Kind of slipped a little bit. And then I'll connect this one. So it looks like I get two solutions here because I noticed that this parabola cuts the x-axis at two places, here and here. So I have two real solutions. So when it comes to solutions, you're just counting how many times does the parabola touch the x-axis when it cuts through it. So there are 2 points here. All right, let's work out some factoring problems. So we're getting now into solving quadratics using algebra instead of graphing here. So with this next problem here, we have a factoring problem. So you don't need to solve, you just need to write it as a parentheses in 2 factors. When I see a problem like this, I notice that there's a number in front of x squared, and this is where I might want to factor using slide and divide. Whenever there's a number in front of x squared that's not a 1, I generally use slide and divide. So if I slide the a over to c, if we write this as standard form, 3 times 15 gives me 45. Now from here, I'm thinking about two numbers that multiply to give me 45, but add to give me 14. So I'm thinking perhaps it's 9 and 5, because 9 and 5 multiply to give me 45, and 9 and 5 add to give me 14. So this could possibly work. Now I just need to think about the signs here. So if this is x, this is 9 and 5. Maybe they're both negatives because I noticed this here is a positive, so they need to multiply to give a positive number, but they also need to add to give a negative number. So negative 9 times negative 5 does give me 45, and negative 9 plus negative 5 does give me negative 14. So in this case, it works, but don't forget, you've slided, you have factored, you haven't divided. So make sure you divide off what you multiplied or what you slided with. So in this case, 3. If I divide by 3, notice that this x here divides, or this 9 here divides nicely with 3. 9 divided by 3 is 3. But this one doesn't. And so what we learned is if it doesn't divide nicely, just put the 3 in front of the x, because you would just multiply in this factor with the 3. So this would cancel, but there would be a 3 in front of the x. So this would be 3x minus 5. And there we go. We now have our factors. So if I were to multiply x with 3x, I would get that 3x squared. If I multiplied the negative 3 with the positive 5, I would get the positive 15 that I'm looking for. So that is going to be my factors. All right, let's get into solving now that we're warmed up here. So when it comes to solving, we have to generally try to get x by itself, and there's many ways to do it. Like with this one here, this might be more of a square root method, because what I notice is that the x squared is almost by itself. I could just add over 100 to remove the 100, x squared would come down, and this is 100. And then to try to get rid of the square, I can take a square root, and then the square would cancel with the root, and this side would be 100. But you guys probably could catch my mistake. I need a plus and minus in front because you have a positive 10 and you have a negative 10. All right, and that's it, and x is by itself. So the square root method is essentially trying to get the x squared by itself, so that way you can take a square root and get your solution. This one here is a little bit different. Also, I could use a square root method here, so possibly square root method as well, where I can subtract over 45. It's easier to subtract 45 over. If I were to divide by 5 first, I would have to divide this number by 5, this number by 5, and this number by 5. Essentially, when you divide, you have to divide everything by 5. So it's easier to move over the 45 over first, because I only have to do that once. So now this is negative 45 on this side. Now I can try to divide off 5. And so if I divide that off, x squared comes down, and this is negative 9 on this side, because negative 45 divided by 5 is negative 9. Now I need to take a square root to get rid of the square, but I notice on the right-hand side, this is a negative root. So anytime you have a negative inside a root, you have an imaginary number. So I have I square root of 9 is going to be, oh, let me not write that I just yet. Square root of 9 is 3, and I'm going to write the I next to it. So I have a negative number, so I have an imaginary number. That's why I wrote the I. Square root of 9 is 3, and also you took a square root, so this is a plus and minus 3. So a lot of things here that's going on. Anytime you take a square root, you got to have a plus and minus. And anytime you have a negative number under the root, you have an imaginary number. So don't forget using the I to represent that. All right, so in the next problem here, it looks like we have some parentheses. With this one here, I know that if I were to maybe move the 3 over and try to get rid of the square by taking a root, I can slowly make my way into getting x by itself. So perhaps this is also square root method. So what I can do is subtract off the 3 first, move down the x minus 2 squared, and so this would be 16. To get rid of a square, I can take a square root. That would cancel. And now I'd just be left with the inside of the root, which is x minus 2. Square root of 16 is not too bad. It's a 4 plus and minus. Some people will notice that they have two solutions because they have a 4 and a negative 4, but they still need to move the 2 over, so they might split this equation into 2 equations. So x minus 2 equals positive 4, and x minus 2 equals negative 4. and then they will start moving over the 2. So I'll add 2 to this side, I'll add 2 to the other side. So it looks like my x is going to be equal to 6, and x is going to be equal to -2 on this side, because -4 plus 2 is -2. So I have two solutions, x equals 6 and x equals -2. All right, in the next problem here, this one has 3x plus 5 squared, and this side's 27. So maybe I can move the 3 over and then take a square root. So again, this one might be another square root method. It looks like a lot of these problems you can use square root method. So if I were to divide off 3, because this 3 is sitting next to the parentheses, that would cancel. So I think it'd be easier to just divide off the 3 first. So 27 divided by 3 is going to give me 9. I can also take a square root of 2, or the square root of the square to cancel out. So x plus 5 comes down, and then 9 here, let's see, the square root of 9 is 3. And I would have a plus and minus sign in front. So again, I might want to split this up into two equations. X plus 5 equals positive 3, and x plus 5 equals -3. So from here, maybe subtracting the 5 to the other side. Looks like my x is going to end up being -2. 3 minus 5 is -2. If I subtract 5 to the other side on this one, x equals -8. -3 minus 5 is -8. All right, and that is part D here. For part E, we have a lot of stuff going on as well. We have a -45, a 2, but again, I can move all of this over using the square root method. I think you guys are probably tired of me saying this, so I can add over 45 and move that over. My goal is to basically try to get to the x, and it's on the inside of the parentheses. So that means I only have a 2x minus 6 squared here. 53 plus 45 is going to give me 98, I believe. And so I could divide off 2 to cancel out that piece. X minus 6 squared would come down, and 98 divided by 2 is going to give me, I think maybe 49, but I'm just going to double check here using a calculator. And I do get 49. So from here, the rest is pretty simple. I got to take a square root to get rid of the square. X minus 6 comes down, and 49 is going to give me 7 if I take a square root. So I have plus and minus 7. So I can split this up into two equations. It looks like I have x minus 6 equals positive 7, and x minus 6 equals -7. So I'm just going to add the 6 over to both sides. So my x is going to be equal to positive 13, and x is equal, on this side, -7 plus 6, which is -1. And those look like my two solutions. All right, for f here, we have x squared plus 3x minus 18. So finally, we get something that looks completely different to what we have seen so far. The ones that we've seen, it looks like it's just like two terms. Like notice there are two terms on this side, even though there's a bunch of stuff on the terms. This one's also considered two terms, 1, 2. Basically, you know how many terms there are with the separation of plus or minus signs. This one here, also two terms. Whereas for part F, there are 3 terms. So perhaps it might be nice to try to factor by thinking about what two numbers multiply to give me 18 but add to give me 3. And the side's still 0. So I'm going to put my x's down. And two numbers that multiply to give me 18 could be 3 and 2, maybe 3 and 6. So if I multiply 3 and 6, I could get them to add to be 3 if I make one of them a negative. So maybe the 3 is a negative and the 6 a positive. So 6 times 3 does give me -18. And 6 plus -3 is +3. So this might work. And then once you factor, you can just set them equal to 0 and find the x. So I would subtract 6 over with this first one, add 3 over with this one. So x equals -6 and x equals +3. And there we go. We have our solution. All right, so we did a lot of solving with these, and you'll definitely encounter problems where you have to solve for a quadratic. But the next thing I want to mention is about simplifying expressions with imaginary numbers. So as a quick reminder, anytime you have imaginary numbers, like we learned that I is basically representing a negative number inside a root, but I squared, which is probably more important, is representing -1. So we often use this one a lot in mathematics to use as a substitution. So anytime you have I squared, you replace it with a real number, which is -1. So if I were to encounter this problem here, I might start off with foiling and foiling out like 2 times 4i, which gives me 8i. 2 times -5 is -10. 3i times 4i makes it a positive 12i squared. Notice there's a square here because 2 i's make an I squared when you multiply. 3i times -5 gives me -15i. So when I look at this here, I notice that there's an 8i and then there's a -15i, so I can combine those. So 8 minus 15 makes a -7i. And then I'll bring down the -10 and the 12 here, the 12i. So this I squared ends up being replaced with -1 because we mentioned before, -1 here is your I squared. And so this would give me a -7i in front, -10 minus 12, because the -1 times 12 makes it a -12. So now I can combine these two numbers. So -10 minus 12 is going to give me -22, and I have a -7i in front. By the way, the order of which one comes first, I or the number, doesn't really matter as long as you have the sign correct. So you have a negative for the 7i and a negative for the 22. And this would be my solution because I can't combine an I, an imaginary number, with a real number. So let's try another one here. So this one, oftentimes people, when they see two parentheses, they try to FOIL, but this just says to add this here, this parentheses with this parentheses. So if I'm just adding, I just combine like terms. So I'm going to take the 3 and combine it with the -10 because those are like terms. So 3 minus 10 is going to give me -7. And then the I plus 5i is going to give me positive 6i. And so I'm done. This would be my final answer because I can't combine a 6i with a 7, a number. So this is it. So you're just combining like terms if you're adding two parentheses. So I added the numbers with the numbers and the i's with the i's. Okay, with C here, I do need to distribute this 3i into the parentheses since it's in front. So I would get 15i minus 21i squared. So 3 times 7 gives me 21, and I times I gives me I squared. So I would have 15i minus 21, and the I squared is really going to end up being -1. So two negatives end up making a positive 21, and this is a 15i that comes down. So I've made this into a real number, and this 15i just drags down, and I can't combine anymore, so this is my final answer. So in the next problem here, we have one that also has parentheses, but this time there's a minus sign. So the only difference between this and addition is that you have to distribute the minus sign. If you don't, you might make a mistake with the signs. So we'll bring down the 4 and the 2i, and we'll have a positive 7 and a positive 3i. If I combine the like terms, 4 plus 7 gives me 11 here, and then the 2i plus the 3i gives me a 5i. And I can't combine this any further since they're not like terms, so this is it. All right, so kind of coming to our final last problems here. So this one is giving us a really big hint to use the quadratic formula. And I think this is the case because 5 is a prime number. So there's only two numbers that multiply to give us 5, 5 and 1, but they don't add to give us 2. So in this case, we probably have to use quadratic formula because this is not factorable. So if I use quadratic formula, our A is a 1, our B is a 2, and our C is a 5, and this side needs to be 0, which is it. So it's in perfect form for quadratic formula. And just as a quick reminder, the quadratic formula, I'll write to the side here. I would definitely have this as in your notes or on your review. If you're taking the final, you definitely need to know this formula. So if you guys know Pop Goes the Weasel, goes like this. X equals negative b plus or minus a square root b squared minus 4ac all over 2a. And using this formula here, I'm going to plug in my b value, which is 2. So if I plug 2 in for b, I would have negative 2 plus or minus the square root b squared, so 2 squared. So I'm plugging this 2 in for this b and writing it here, minus 4ac. So my a here is 1 and my c here is 5, so I'm going to plug those in. So 1 and 5 are my a and my c, all over 2a, so my a here again is 1. So working this out, let me zoom in just a little bit. If I were to work this out here, let's clean up the root. So I have a negative 2 on the outside, plus or minus the square root. And 2 squared is going to give me 4. We always do exponents first because of our order of operation. There's a negative sign here, so I'm going to drag that down. 4 times 1 times 5 gives me 20, all over 2, because 2 times 1 is 2. So if I subtract the inside of the root, I get 4 minus 20 is negative 16. And so from here, if I were to take the square root of 16, this is a negative square root of 16. So this ends up being negative 2 plus or minus 4i, because there's a negative, but the square root of 16 is 4 for sure, and I is just going to sit next to it. So this x comes down, and I'm bringing down the denominator. So I notice that all of these numbers here, I'm dividing by 2. So if I were to divide 2 by 2, let's write to the side here. I would get x equals negative 1 plus or minus. So I've taken 2 divided by 2, got a 1. Taken 4 divided by 2, get a 2, and then the I next to it. So I've divided this by 2, got the 1, divided 4 by 2, and I got a 2. So it looks like x equals negative 1 plus or minus 2i. So yeah, that would be really hard to factor. So quadratic formula is a great one for this. This one also seems to want us to use the quadratic formula to solve out this equation. So if that were the case, it looks like my a here is 3, my b is a 1, and my c is a negative 1. And it's already in standard form because this side is 0. So if I were to be solving this, let's use a quadratic formula. So x equals negative b, which in this case is 1, plus or minus the square root. B squared, so 1 squared minus 4ac, my a being 3, and my c being negative 1. And this is all over 2a. My a is going to be a 3. And so I'm ready to solve and simplify. So I've had a negative 1 in the front, or in the top here. I'm going to simplify the square root. So 1 squared is just 1. And then when I'm multiplying these three numbers, I'm going to count the signs first. There are 2 negatives, so I know I'm going to be a positive sign because 2 negatives multiply to make a positive sign. And then I'm going to multiply the actual numbers. So 4 times 3 times 1 gives me 12. On the bottom is a 6 if I multiply the 2 numbers in the bottom. Now if I add the inside of the square root, I get 13 over 6. Now, at this point here, I don't think there's much I can do. The square root of 13 is a prime number. You're not going to be able to decompose 13 any more than 13 times 1. So I have to keep this under a root, and I can't add a root with a 1. Also, I can't divide by 6 because nothing evenly divides. So this is it. This is going to be my final answer. Alright, so I know this video was long, but this was basically everything we've learned in the quadratic chapter, so it is a lot to take in. look over the stuff that is confusing and maybe rewatch those problems. But that's it for this video. Bye, guys.